Problem 56, chapter 6. I would say this problem is a challenging one, and I would encourage you to think about it for at least 30 minutes to an hour before seeing the solution. Here we have this bar, which is on this corner, and we are releasing it when it is in the vertical direction, slightly lean to the right. Then it's gonna rotate about this point, and then if you check it with you, if you actually do this practice at home, you can see if you put a pen on your finger and release it, it's gonna rotate to some angle, then it's gonna jump over, it's gonna slide over. And this question says, after releasing this bar from the vertical direction, it's gonna rotate about 0.0, and when it reaches to 30 degree, it's gonna slide down. Before that, we are gonna have contact between the bar and this corner, but after 30 degree, it's gonna release and it's gonna slip. And the question is, what is the static friction coefficient between the bar and this corner? Okay, to solve this problem, first of all, as always, we need to draw the free body diagram. We have this bar, and we are gonna have gravitational force at any given angle like theta. We have this mg, and also we are gonna have a normal force and also the friction force, right? So the normal force is gonna be along the bar, let's call it n, and the friction force is gonna be against the direction that is trying to slip, right? So let's call it F. Now, at the moment when it starts to slip, there's gonna be a relationship between F and N. F is gonna be equal to mu S times N, right? But before it's starting to slip, F is gonna be always less than mu S times N. However, F and N, they are not constant numbers. They are changing by changing the direction of this bar, right? They are changing at any moment. So the problem is kind of complicated. We need to find F, we need to find N, both of them in terms of theta. So we need to find general equations for them. And then put F is equal to mu S times N when theta is equal to 30 degree. And from there, we should be able to find mu S. So my goal is now finding F and N. Okay. To do that, this angle is theta. So I'm gonna call angular velocity omega in this direction, in the direction of increasing theta, and angular acceleration alpha. And we know none of them. By writing some of the moments about point O, I'm gonna be able to find alpha. Let's do that. Sum of the moments about point O is equal to IO times alpha. This equation is valid before starting to slip, right? Because it is rotating about a fixed point. This body is rotating about a fixed point, so we can write this equation for it. And moment about O, we have these two forces, they are not making any moment about point O. The only force that makes moment about point O is mg, and the moment of it is going to be mg times half of L times sine of this angle, sine of theta. And it is in the direction of alpha, so I'm going to consider this direction, clockwise direction, positive here. So I'm going to have mg L over 2 times sine of theta is equal to IO times alpha. For a bar, if you remember, mass moment of inertia, but the center of it is 1 over 12 mass times L squared. Mass moment of inertia, about one corner of it is going to be 1/3 times m times L squared. So IO is 1/3 of ml squared times alpha. From here, by simplifying, canceling out this m and one of these l's, alpha is going to be equal to 3/2 of G over L times sine of theta. So this is alpha in terms of theta. So we know what is alpha, what is the angular acceleration at any alpha. Then if I want to write the other equations, for example, some of the forces in the normal direction is equal to mass times acceleration in the normal direction. Let me start doing that. Sum of the forces in the normal direction. What is the normal direction? This is going to be the normal direction from the center to the center of rotation. This is my normal direction, and this is going to be tangential direction. Sum of the moments in the normal direction is equal to mass times acceleration in the normal direction. But what is acceleration of the center in the normal direction? It's equal to velocity squared divided by r, or r times omega squared. Both of them are the same, right? So it's going to be mass times r times omega squared. And what forces do we have in the normal direction? This is the positive direction for normal. It is mg times cosine of theta minus n. Mg cosine of theta minus n is equal to mr omega squared. And I would like to find n, because as I told you, if I find n and f, then I can set f is equal to mu s times n to find mu s. That's our goal. But in order to find n, I need omega. I don't know what is omega, right? I only know omega at the beginning is equal to 0. But what is omega when theta is equal to 10 degrees or 15 degrees, 30 degrees? We need to find that. How can I find omega? I have only alpha. Can I find omega from alpha in terms of theta? Of course I can. If you remember, we had this equation, alpha d theta is equal to omega d omega. Time independent equation. And this is going to be useful because we have alpha in terms of theta. If I put it here, everything is going to be in terms of theta here. So I can integrate it. Also, I can integrate the other side because everything is in terms of omega. So I can find omega from there. So alpha is equal to 3g divided by 2l sine of theta d theta. We are integrating from theta is equal to 0 to any particular theta. It's going to be equal to integral of omega d omega from omega 0 to omega at this theta. Omega when theta is equal to 0, it's 0. And omega at theta is going to be something that we are trying to find it. So integral of omega d omega is going to be half of omega squared. It's going to be equal to integral of sine is going to be negative cosine from 0 to theta. It's going to be 1 minus cosine of theta. So from here, omega squared is going to be equal to 3g divided by L times 1 minus cosine of theta. Excellent. We found omega in terms of theta. So now I know what is omega at any point, at any theta. Right? And also I can put it here to find n. So let's name this 1, 2, and 3. Combining 2 and 3, n is going to be equal to mg cosine of theta minus m times r times omega squared, which is this. And by the way, r means L over 2 here, the distance between the centroid and the center of rotation. So let me change it here. Mr times omega squared, which is 3g divided by L times 1 minus cosine of theta. L is going to cancel out, and if you simplify it, n is going to be equal to mg divided by 2 times 5 cosine of theta minus 3. So we found n. The only other thing that I need here is finding the friction force. How can I find the friction force? I can write the Newton equation in the tangential direction. Sum of the forces in the tangential direction is equal to mass times acceleration of the centroid in the tangential direction. If you look at our free body diagram, the forces that we have in the tangential direction is negative F and mg sine of theta. So negative F plus mg sine of theta is equal to mass times acceleration of the centroid in the tangential direction. Okay, the centroid is rotating about point O, so the tangential part of the acceleration of it is going to be r times alpha, right? And alpha is in counterclockwise direction, so AT means in this direction. It's going to be in this direction. So it's going to be half of L times alpha. Unfortunately, we know what is alpha. Alpha, we found it here, right? So if I replace it here, replace from 1 here, then I can find the friction force. If you do that and simplify it, the friction force is going to be equal to mg divided by 4 times sine of theta. So we are done. We found the friction force, we found the normal force. Now, at the moment of sleep, when it starts to sleep, we have friction must be equal to mu s times n. So from here, mu s is going to be friction force divided by n. So it's going to be 1/4 of mg sine of theta divided by 1/2 of mg times 5 cosine of theta minus 3. You can simplify m, and at the end it's going to be sine of theta divided by 2 times 5 cosine of theta minus 3. So if it starts to sleep at any specific theta, we need just to put it here to find the mu s. The problem says it's going to sleep at theta is equal to 30 degrees. So if you put theta is equal to 30 degrees, mu s is going to be equal to 0.1880.